So now let's take a brief but a little bit more in-depth view at OpFlex Protocol. So this is a flexible, extensible, policy-based protocol. It's the new resolution protocol designed to declare our intentions for group-based policy, really for any data center infrastructure. So unlike legacy protocols such as OVS-DB, which is it's actually a database and a protocol, the Open vSwitch DB protocol is what controls from a open flow server is what controls the OVS or Open vSwitch running on a hypervisor. That was very imperative. So we talked about the difference early on about imperative versus declarative. If I want a cup of coffee and I simply tell my assistant, I don't have one, I wish I did, go get me a cup of coffee. First, I would hopefully use the word please. Declarative in data centers doesn't need to, right? So if I just said, go get me a cup of coffee, I'm declaring my intentions. And that's the idea of OpFlex. If I were using OVS-DB protocol to tell him or her to get me a cup of coffee or a switch what to do, I would have to be very iterative, step by step. So stand up, turn right, take 5 steps, turn left, turn right, or I guess walk 2 steps, turn right, push the door open, and so on and so forth until they were all the way to the coffee machine, made me some Nespresso, brought it back, delivered it, and handed it to me. And I'd have to be imperative the whole way. It's very tedious, and the problem is that it's different for every device. So that's one of the big problems with OVS-DB in that it is not terribly scalable. I have to be very imperative, very iterative, very specific with every new device that I create and create policy for. So the scalability kind of goes right out the window. Vendor interoperability goes completely out the window. We have to be, well, it's still technically supported with almost any vendor today. Even Cisco has the Nexus 9K and standalone that supports OVS, but we have to tell it what to do at every single step along the way. So with OpFlex, we simply declare the policy, and as long as it's following OpFlex and group-based policy, it will instantiate those requirements or take the logical model and render an implicit concrete model, which is actually what we're getting ready to talk about next. Before we move on, this would be supported really on any device. It is what the APIC uses to control the Nexus 9Ks. It's what it uses to control the AVS switch that we'll talk a little bit more about. It can be used to control a firewall, any sort of ADC, load balancers, etc., any other hypervisor switch, even any sort of legacy switch, Nexus 7K, Cat 6K, whatever has implemented the OpFlex protocol and group-based policy. It's published in the draft-smith-opflex-00. That's actually, I believe, been superseded by a -01 now because drafts time out after it's either 6 months or 12 months. So they have to keep getting renewed. And it has been renewed, actually I think twice now. We might be on 02. But it should be ratified as a standard here, hopefully very shortly. So an idea of the logical framework of the OpFlex protocol, we have the policy element that declares endpoints in groups and requests information about those and gets policy update from the endpoint registry. We also have the policy repository where the logical model is defined and then sent down to the policy element, which would be like a switch, vSwitch, hardware switch doesn't matter, firewall, ADC doesn't matter. As long as it's running OpFlex and the policy-based, group-based policy, then that logical model will implicitly render a concrete model, which will translate to things on that device, physical or virtual device. So ports, VLANs, interfaces, routes, security, ACLs, whatever the case may be, virtual IPs, VIPs for load balancers, ACL rules for firewalls, whatever the case may be. That gets deployed to the actual network hardware in the policy element, and we always get state reports. So we always have this observer module that gathers statistics, events, faults, audit logs, things like that. So we talked about how this looked, this APIC, or I guess I should say how the OpFlex policy group-based model looked in the APIC earlier, in fact in pretty much the first module, or second module rather, where the APIC has the policy controller, and the logical model creates the subset of the logical model on the network device, so let's say the leaf switch, and that implicitly renders the concrete model out to ports, cards, interfaces, VLANs, nodes, etc. And that gets pushed into the NXOS process and deployed onto the network gear. So one other thing, and this slide is a little bit out of order because we're going to now talk about application virtual switch, or AVS. So AVS was really the first virtual leaf to implement OpFlex. Okay? There, of course, we're already implemented with the hardware switch, but the AVS is essentially the software-based switch that replaces whatever vendor-specific or open source like OVS is running on the hypervisor. So in the case of VMware and vSphere and our ESXi hosts or hypervisors, they have their own, of course, VMware standard switch, and they have the DVS as well. Both of those still control essentially the same subset of virtual switch software components nested at the kernel level in ESXi hypervisor. And the AVS, the difference is it still creates a DVS, but it, at this point, is a new, and we'll talk a little bit more about it, but it's a VIB file, so it's a new software package that either gets manually or automatically pushed down into the hypervisor and can be used as an alternative to the VMware, the old legacy VMware switch that's built in. So with this gives us a lot more increased control plane scalability. Now remember, AVS used to be the only way that we could control a hypervisor in ACI 1.03 or 1.0 for 1.0 anything, if we were more than one external non-managed layer 2 hop away. Now that we have pre-provisioning, we don't necessarily need AVS for that reason, but there are many other reasons to use that. In fact, we're going to have a module all by itself, just on, or really probably be an extension module to this is how I'll probably do it, just on VMware attributes, micro-segmentation, micro-EPGs, and distributed stateful firewall with ACI. So ACI provides all of that today, and it does it through the application virtual switch. So you do need AVS to have all of this enhanced functionality of micro-segmentation of VMs with their micro-EPGs, their distributed stateful firewall rules, things of this nature. So as I mentioned, there's three different options. We have the distributed virtual switch, native built-in, VLAN only, LLDP or now pre-provision. And it should be noted that DVS, whether we're using it as a standard DVS, whether we are using vCenter with vShield, or whether we're using AVS, which creates a DVS but replaces the software that's running the actual virtual switch, all three of them need the vCenter with Enterprise Plus licensing, and vShield needs the additional vShield licensing. And actually, I haven't really run into any customers that are running vShield just because of the high cost of that additional vShield licensing and other better options that are out there today, such as AVS. I don't need that additional licensing. It doesn't cost anything from Cisco. So if you want to run AVS on all your hypervisors, you could have 1,000 or 1, and it's not going to cost you any difference. As long as you have the APIC cluster and an ACI-based infrastructure of at least 2 spines and 2 leafs. But that's the base that you need. So with that, I could have all of my VMs controlled through OpFlex, through AVS, and they could be attached to my leafs. They don't have to be attached to my leafs. It really makes no difference. Notice the encapsulations with the standard DVS is VLAN only. With vCenter and vShield, we have VLAN or VXLAN options. Same with AVS, we can either do VLAN or VXLAN. The installation of these two is built in. You have to install vShield, but in terms of the hypervisor, it's native because it's just using VMware's legacy virtual switch. So with AVS, the installation is done through a VIB file, and this can be installed in a number of ways. Manually on the console of the ESXi server, it can be done through VUM, which is VMware Update Manager. And yeah, so the VIB can deploy the VEM through the VUM. Okay, try to say that 3 times fast. The VIB, I don't remember what this stands for, but that's VMware's file extension naming for any additions or plugins that go into an ESXi hypervisor host. The VEM is the virtual Ethernet module. So the AVS was built from the Nexus 1KV virtual Ethernet module. It does not have a VSM or virtual supervisor module like the Nexus 1KV did, and it's not just the Nexus 1KV VEM. So it used the base code, but it's been completely enhanced to support OpFlex Protocol, to support group-based policy, and to work specifically with the ACI APICs as the controllers. There's also another thing that we'll talk about here in a moment, another way to install AVS. So with AVS, we have a few different switching modes that we can choose from, 2 of which are supported today, and 1 is supported in the very near future. I think it's actually coming here in just a couple months. So we have, since AVS 1.0, we've supported 2 modes, non-switching mode and local switching mode. Non-switching is also referred to as FEX mode. Now currently we're on AVS 2.0, and of course they still support both of these as well. 2.1 is the release that's just mere weeks away, really months away in the sense of a couple months. So with AVS 1 or currently 2.0, in FEX or non-switching mode, essentially if we want to go between VMs inside of a single EPG, so intra-EPG, we still have to punt all traffic to the leaf for switching and for policy. And again, policy in terms of who can communicate to who, inside of an EPG, everyone can communicate to everyone. So there really is no policy that needs to be applied, but we may need will need layer 2 switching or possibly layer 3 routing if these VMs were on different subnets, but in one EPG, one bridge domain, and it had 2 subnets, so an IP and a secondary IP. Now, going inter-EPG, regardless of whether we're using FEX mode or local switching mode, they both require today being punted to the leaf for layer 3 routing, as well as for policy application. Now, this is something, as I mentioned, that in just a few months, the full switching mode will be out, and inter-EPG will be supported, and not just layer 3 routing, but also policy as well. So, not sure why you would want to use the non-switching mode. You could use that FEX mode. A lot of people actually do use that for wire speed routing, or really wire speed switching. So we want essentially that performance gain that we get from switching with hardware ASICs. And then you have the option of doing local switching mode where intra-EPG is then switched locally, inter-EPG is switched at the leaf. So we also have the VSUM, or Cisco Virtual Switch Update Manager, which allows us to install AVS. So with this, we have the ability to install the AVS into the ESXi hosts, as well as migrate them, migrate the VMs, and migrate the hosts over to the AVS. And this was originally built for the Nexus 1KV, so that's why it says that here. But of course, it works with AVS as well. We can also upgrade and monitor our hosts and monitor the virtual network. And it's planned that we'll even be able to configure port profiles. But at this point, what we'll probably do is just use the ACI plugin rather than necessarily doing it through this interface. This is done through the VMware vSphere web client. It's only available. And what it is it's actually an OVA that you can download from CCO or Cisco.com. And you install this, or really just bring up this virtual machine on your network, and it will ask you a couple quick wizard questions at the command line. What is the vCenter IP address, username and password, and then it will install this plugin, which will allow you to very easily distribute the AVS into your ESXi hypervisors. So the workflow for the AVS would be to create the AVS configuration via the APIC. So create the DVS and the uplink port group. The VTEP port groups is another port group, and you can read through the documentation that you need for the VM kernel NIC. So you don't necessarily have to migrate VMK0, but you do have to create a virtual machine, or sorry, a VMK, a VM kernel interface on each ESXi host and assign that to the AVS, just like you had to do with Nexus 1KV VMs if you've ever worked with those. And then you enable the infrastructure VLAN in the AEP. Now remember, I had mentioned previously that, and I can't remember if I mentioned this in an earlier module here or earlier subsection of module 7 for VMM integration, but whenever we're creating an AEP, or that software glue, the attachable entity profile, actually by default, the tick box for infrastructure VLAN is ticked. You always want to untick that box unless you're creating an AEP specifically for AVS. And the reason is, you remember back to one of the first modules, we talked about that wizard that when I first bring up an APIC, it asks me those, 9 or 10 questions. What's my fabric name? How many APICs am I going to create in the cluster? What is this APIC number and name? What is the infrastructure IP range, which by default was 10.0/16? And then what was the infrastructure VLAN? And the APIC communicates to all of the leaf switches via the OpFlex Protocol, including the virtual switch, the AVS, through that infrastructure VLAN. So if we create an AEP and we tick the box or leave it ticked for infrastructure VLAN, then it's only going to have that VLAN ID on whatever switch port trunk, whatever switch node and interface profile are attached to this AEP. So you do want to create a very specific interface profile, port, and attach it to a very specific switch or pair of switches like a VPC for where we're going to propagate out that infrastructure VLAN. And remember, outside the fabric, that VLAN has to be created in the VLAN database and has to be permitted on the trunk, not only from the external, let's say, pair of 7K switches to the ACI leaf switches, but also past those 7Ks down to your 5Ks and down to your ESXi hypervisors that are outside the fabric. So all of that is required that VLAN be able to traverse all of those. So that's why it's very important not to choose the default VLAN of 4093. That's reserved, especially in the 7K, for instance, for supervisor to line card communication. So you want to choose a VLAN. TAC recommends VLAN 3967, which is the highest numbered VLAN that is not yet used by any other Cisco device, any other Cisco switch that might, Catalyst or Nexus. I actually ran into a customer, they wanted to use AVS, but they had already used all the VLAN 3000s that they could, up to including 3967. So they never used VLANs 1 through 10. So we never used VLAN 1, they picked VLAN 3, and we used VLAN 3. It doesn't matter as long as it's not used anywhere else in your enterprise or the rest of your data center outside the ACI fabric. And remember, you will also never create an SVI for this. If we created an SVI, we would have the 10.0/16 network as routable outside the fabric, and that would most probably overlap with the rest of your RFC 19, 18, 10.0, probably /8 that you're using cut up into various VLSM masks. So never create an SVI for that. But do make sure that the VLAN you choose is done when you first create your APIC. And by the way, let's say you're now watching the AVS module and you'd watched all the other modules and you had already deployed your fabric and you had decided you weren't going to do AVS, and then later you realize, oh, there's a lot of good features: microsegmentation, distributed firewall, soon to be local even layer 3 routing and policy. There's a lot of good reasons to use AVS. So we're now thinking we want to, but we never changed the default VLAN of 4093. Well, you're not really that far out of luck. What you can do, and this sounds scarier than it is, it's really not bad at all, even in a production environment, is you can simply back up your whole or export your whole configuration from the ACI APIC, and hopefully you have that scheduled to occur regularly anyhow. And then from there, you can wipe your whole fabric clean. Now, this is obviously service impacting, but you would wipe your APICs, all 3 of them. There's a shell script you can run. You would wipe each of the leaf and spine switches with a shell script, and then you would bring your APIC and bring all your leaf switches back up for the first time, and you would run through that wizard again, and you would fill in the new values. And the new, probably main new value would be that infrastructure VLAN, let's say 3967, or like my other customer, VLAN 3, whatever you choose that's not being used anywhere else in your legacy data center infrastructure. Okay, so just kind of a brief side-by-side comparison of VMware DVS, various features, AVS 1.0, what we're currently running on 2.0, and coming out here in just the next few weeks, 2.1. So 2.1 is where we're going to get that enforcement policy and virtual leaf, full layer 2 network, full layer 3 network as well, and atomic counters. AVS 2.0 does have distributed, actually this says AVS 1.0 has the distributed, that's kind of a typo. It should be AVS 2.0 has, that was a copy paste error, has the distributed firewall, microsegmentation, and EPG. AVS 1.0 does not have that. So in summary, Cisco's committed to Cisco's virtual switching on various hypervisors. And actually, I want to point out something that you've probably heard, or if not, will hear in various media, which is that VMware has basically said that they don't support AVS any longer. They did on 5.5, and they don't on 6.0, and that's for various obvious reasons, competitive with their own solution for NSX or microsegmentation or their own virtual overlay solution. And the thing is that honestly, Cisco's never asked anyone to support their product, right? So Cisco created the AVS product and they fully stand behind it. Don't let that FUD, that fear, uncertainty, and doubt concern you in any way. AVS is a tremendous product. We can identify and classify VMs. In fact, we're going to do this in the demo portion with what we call attribute-based micro EPGs, microsegmentation, and distributed stateful firewall. We're going to do all this, and once you see this, don't worry about VMware saying they won't support it. Cisco stands fully behind their products, and they do support that. So we can use VSUM as a simplified installation and monitoring. AVS 2.0 is available now, and 2.1 in the just coming few months, and AVS for vSphere is available now. Other hypervisor support is in planning, and the full switching is coming very soon, as I mentioned. So a few design considerations. We kind of talked already about the endpoint discovery and how we used to need LLDP or CDP. Today we can actually do this through pre-provisioning. The data path learning is done as we see the VM transit or transmit really the layer 2 Ethernet frame with a .1Q VLAN header, or optionally layer 3 header with a VXLAN header if you're running, let's say, Microsoft, or sorry, not Microsoft, but vCenter with vShield. Also, we could identify that from NSX. So I actually have done implementations where the customer had already bought NSX. I've done 2 of these now. And they later decided, you know what, we want ACI. but we already spent the money on NSX, so can we marry the two together? I mean, NSX is just an overlay. It still needs a hardware underlay. So can we combine these two? And NSX actually runs much better on top of ACI than it does just on any other infrastructure. So even if you've already gone down that route, there's still plenty of reasons Lumos can talk to you about why to run ACI as your infrastructure and tie that in and couple that closely. So some of these are done away with the need for the or with the ability of pre-provisioning, but hosts are assigned the VXLAN VNID or vSID if it's Microsoft Hyper-V and NVGRE to the EPG binding through the Virtual Machine Manager and APIC integration. The infrastructure VLAN is extended out those front panel access ports in the case of AVS, the Application Virtual Switch, controlled through OpFlex. And then just real briefly taking a look at Hypervisor integration roadmap. Some of this is current, so actually a couple things here that is not current, specifically that Microsoft is demo only. That was, I forgot to take that out. That's actually now available with both System Center VMM and Azure PAC, KVM, Open vSwitch on Red Hat KVM with the OpenStack group-based policy plugin. This is actually now available as well. And AVS 2.1 is coming soon. VMware 6 support is coming very soon.